Hello everyone and welcome back. In the previous sessions, we have learned about the subtraction in binary number system. In this session, we are going to learn about the subtraction in hexadecimal number system. So without any further ado, let's get to learning. Coming to the topics that we are going to cover in this session, at first we will understand about the borrow in different number systems. There is the concept of borrow in both binary and in decimal number system. Then we will learn about the subtraction in hexadecimal. Let's now understand about the borrow in different number systems. Now, as I mentioned earlier, we are going to learn about the borrows in binary and as well as in decimal. Let's begin with binary. Now, in order to understand this concept, which I am about to illustrate, let's perform a subtraction in binary. And this time, the minuend is going to be 1, 1, 0. And the subtrahend is going to be 0, 1, 1. So let's begin. Consider the first unit, that is the least significant bits. In the minuend, the bit is lesser than the subtrahend's bit. So we need to borrow in this case. Now in order to borrow, where we are going to borrow it from? The next bit, right? So from 1, we will borrow 1. So what we will be left with? It is 0. Since we are borrowing 1 from 1, definitely we will be left with 0. Now it is 1, 0. That is the minuend. Now from 1, 0, if we subtract 1, we will get 1. And the reason for that is 1 plus 1 is 2, which in binary is 1, 0. Focus on the next unit. Now here, the minuend is 0. Since we borrowed 1, that's why we were left with 0. Now considering this particular unit, now the minuend is lesser than the subtrahend. So we need to borrow once again. So where will we be borrowing from? Well, the next bit, right? Now if we borrow from here, we will have 1, 0. And since we are borrowing 1 from 1 only, we will be left with 0. Now notice, this is 1, 0, that is 2. So from 2, if we again subtract 1, we will get the result as 1, that is the difference. Finally, if we consider the most significant bits, both are zeros, that is the minuend and as well as the subtrahend. And 0 minus 0 is 0. Now we already know how to perform this subtraction. So what is so new about it? Notice one thing, when we borrowed this one from this place, did we actually borrow 1? Not really. We actually borrowed 1, 0. And with that 1, 0, we added 0 of the least significant bit. Confused? Let me clarify this with the help of the place values. Notice, the place value of the least significant bit is 2 raised to the power 0. Whereas, the place value of the next bit, that is this bit places, is 2 raised to the power 1. Now, when we are borrowing this one from this place, that is the 2 raised to the power 1's place, we are making the LSB, that is the least significant bit, a 2-bit number. Now, when it is a 2-bit number, the least significant bit, that is this 0, it already has the place value 2 raised to the power 0. Now what about the place value of this bit? It is 2 raised to the power 1. And due to this reason, when we borrowed 1 from here, we were left with 0, isn't it? So every time we are performing the borrow, we are actually borrowing 1, 0. That is 2 of decimal. Notice, when we borrowed this one from this place, we were borrowing it from 2 raised to the power 1's place, and it still had the place value 2 raised to the power 1. Now considering this, we borrowed this one from here, which was initially having the place value 2 squared, and we brought that in this place. So clearly, we borrowed 2 from this place and accumulated that with this place value. So in binary, whenever we are borrowing 1, 0, that is 2 of decimal. Now what about decimal? Well, in order to understand the concept of borrow also in case of decimal, let's perform a subtraction. Here, the minuend is going to be 168, and we will take the subtrahend 79. Now this time, in order to have better clarity, let's consider the place values at first. Let's begin the subtraction now. If we consider the units place, notice the minuend digit is 8 and the subtrahend digit is 9. So the minuend is lesser than the subtrahend. So we need to borrow in here. Now where we will be borrowing from? Well, the next digit, right? That is from the digit of the tens place. So if we borrow 1 from here, in the tens place, what we will be left with? Well, 5. Now notice, did we borrow 1? Not really. From 60, we borrowed 10, so this became 50, considering both these places, isn't it? Now from 18, there is a 2-digit number. If we subtract 9, we will get the difference as 9. Coming to the next unit, we have got 5 in the minuend digit, and it got turned into 5 since we borrowed 1. So 5 we have in the minuend digit, and the subtrahend digit is 7. Now it is lesser than the subtrahend. So again we will have to borrow, and where we will be borrowing from? Well, this time from the hundreds place. Now if we borrow from this place, now it will be 15, and what we will be left with? 0, isn't it? Now from 15, if we subtract 7, we will get the difference 8. Now in case of decimal, every time when we were performing the borrow, did we actually borrow 1? No, right? In order to make the minuend digit of the units place bigger, we borrowed from tens place. So we actually borrowed 10. And also in case of the tens place, when we made the minuend digit bigger than the subtrahend, we borrowed from the hundreds place. That is, from hundreds place, we are borrowing to the tens place. Now notice, 10 raised to the power 1 multiplied with 10 will make 10 squared or 100. So essentially, we are borrowing 10 only. So in case of decimal, we are borrowing 10, that is 10 in case of decimal. Notice, in case of binary also, we were borrowing 10. And in case of decimal, we are borrowing 10, but this time it is 10. However, in case of binary, which was 10, in decimal, that's 2. So do remember this, when we are dealing in binary, we are borrowing 10, but in decimal that means 2. On the other hand, in case of decimal, the borrow's value is 10, that is 10 in decimal. So that's the concept of borrow in different number systems like binary and decimal. Let's now focus on the subtraction in hexadecimal. Now in hexadecimal, we already know we have got 16 symbols starting from 0 to F. Now let me show you how the subtraction is done in case of hexadecimal. We are going to take the minuend as FAB. Well, these all are valid symbols of hexadecimal. And the subtrahend we are considering as AEF. Notice, both of these are 3-digit hexadecimal numbers. So let's have the place values already. Now consider the first unit. We are having the minuend digit as B and the subtrahend digit is F. Since the symbols are involved, we know we will have to take help from decimal. Now in decimal, we have got the symbols from 0 to 9, which we also have in case of hexadecimal. However, we don't have the values for these. Let's have them as well. Now notice, we are trying to subtract F from B. That is, we are trying to subtract 15 from 11. So clearly, the minuend digit is lesser than the subtrahend. So we are going to borrow, and where will we be borrowing from? Well, you guessed it correctly, the next digit's place. That is, 16 raised to the power 1's place. Now what is the value that we are going to borrow? If you remember in the previous session when we learned about the addition in hexadecimal number, we learned the maximum value which we can get by adding two F's is 1E. In that case, E was the sum and 1 was the carry. Similarly, when we are borrowing from here, we are going to borrow 1, isn't it? Now if we borrow 1 from here, that is from 10, right? What we will be left with? The previous value, that is 9. Now notice, we have got 1B. Now let's try to understand what is the value of hexadecimal 10 in decimal. Well, 10 of hexadecimal comes after F, and F in decimal is 15. So the hexadecimal number 10 will have the decimal value 16. Is it clear? So when we are borrowing 1, we are actually borrowing 10. And adding B with 10, we got the value 1B. So clearly, we took 16. Basically, we borrowed it from this place. And then we added b, that is 11, with 16, which will give us the value 27 in decimal. So 1b of hexadecimal is actually 27 in decimal. Now what about f, that is the subtrahend? We all know it is 15, isn't it? Now if we perform the subtraction between 27 and 15, what is going to be the difference? Well, it is 12. 7 minus 5 is 2. 2 minus 1 is 1. Now remember, this is decimal subtraction. And 12 in decimal is actually c in hexadecimal. So for the least significant digit, the difference we will have as c, that is 12 in decimal. Let's focus on the next unit. In the minuend we have got 9, and in the subtrahend we have got e. Clearly it is lesser because e of hexadecimal is actually 14 in decimal. Therefore we need to borrow. And where we will borrow from? Well, the next digit, right? That is this place. And we will again borrow 1 0, that is 16 of decimal. So let's do that. Now if we borrow 1 from here, what we will be left with? Well, the previous digit, that is e. Now what about 1 9 of hexadecimal? Well, we borrowed 1 0, that is 16. However, 9 is same in case of both the number systems. So with 16 we are going to add 9, and the result is going to be 25 in decimal. Hexadecimal e is 14 in decimal. So let's now perform the subtraction. This is the decimal subtraction. So from 25, if we subtract 14, we will get 11, because 5 minus 4 is 1. 2 minus 1 is again 1. Now 11 of decimal is actually b in hexadecimal. So this time for the second unit, the difference is going to be b. Focus on the last unit, that is the most significant digits place. The minuend digit is e and the subtrahend is a. Now e in hexadecimal is 14 and a in hexadecimal is 10 in decimal. So 14 minus 10 will give us the value 4, isn't it? So the result of FAB minus AEF is actually 4BC. Remember, in hexadecimal as well, whenever we borrow 1 0, which is 16 in case of decimal. Let's perform another subtraction. This time we are going to have the minuend as 7788 and the subtrahend is going to be 0DEF. Let's now have the place values as well. Both of them are 4-digit hexadecimal numbers. So the place values are going to be 16 raised to the power 0, 16 raised to the power 1, 16 squared and 16 cubed. Let's perform the subtraction. In the least significant digits place, the minuend digit is 8 and the subtrahend digit is f. So from 8, we are subtracting f, that is 15. So we need to borrow. And we are borrowing from this place, that is 16 raised to the power 1. And what we will be borrowing? 1 0, that is 16. So if we borrow 1 from here, we will be left with 7. And now this unit's minuend will become 18. Let's figure out what it will be in decimal. So we borrowed 1 0, that is essentially 16, and we added that with 8. So let's add that. 16 plus 8 will give us the value 24. Now f is actually 15. Let's perform the subtraction. We will get the result as 9. So in the answer, the least significant digit is going to be 9. Focus on the next unit. We have got 7 as the minuend digit, and the subtrahend digit is e. So from 7, we are trying to subtract 14. We need to borrow once again. Now if we borrow from here, we will be left with 6. Now what about 1 7? We borrowed 1 0, that is 16. And with that, we are going to add 7. Now 16 plus 7 will give us the value 23. And we are subtracting e from that. Clearly, we are subtracting e from 1 7. And the value of 1 7 in decimal is 23. What about e? We all know it is 14. So the difference is going to be 9. Because 14 plus 9 is 23, isn't it? So in this place, we will have the difference as 9. Focus on the next unit. In the minuend, we have got the digit 6. And the subtrahend digit is d, which is clearly 13 in case of decimal. So we are subtracting